Okay, this is Brad and Alex here. We're back with you again to do the next step in creating the program for the Gears bot. And what we're going to do now is we're going to make some code to do the some subsystems to do the elevator and the wrist. Or actually, we're going to do the wrist first, then the elevator. This is actually kind of interesting because both of those have potentiometers on them, so that you can tell what their current position is. And so there's a special kind of subsystem to do that called a PID subsystem. And so we're gonna create those, and you'll see how easy it is to create a subsystem that just uses feedback. So here we go, wrist. So what's going on here is that there are some constants built in. The Kp, Ki, and Kd are the proportional, integral, and differential constants. We'll talk maybe later in another video about how you get those values, but this is the same as you would do if you were just writing the program not using the command-based stuff. And those constants are just there for convenience. And then when we initialize this in the constructor, you can see that we're calling the superclass constructor for the wrist, which is the PID subsystem, and we're passing not only the name of the command, but we're also passing those three constants.
So now we have there's a few known set points that we know we want to be at. We know we want to be towed. We know we want to be able to pick up, so we want to save those values so that we don't have to know what value of the potentiometer is that position.
Yeah, so it's always good. What Alex is doing right now is putting in known positions for these things that we've measured beforehand and giving them names. And it's always good to have named values for these things because then when you see these constants kicking around in your programs, you kind of know what they mean. So pickup is the wrist pickup position for picking up a Coke can, and the stowed position is the position for the wrist to be back up again out of the way. So those are the two. Then those correspond to actually voltages that you get back from the analog input that's connected to the potentiometer. So what happens is that you can just measure that by writing a little program that tests it. And we'll show you more about how to do that later using like the smart dashboard or something. And those become the targets for the PID values.
Okay, so the next thing we want to do is we want to set the default set point that it goes to when it powers on. So we're going to tow it by default. So we have to set the set point to towed, and then we have to enable the PID.
So by setting the set point, that's the target position that the wrist will go to, and enabling it enables this PID controller, so it's just going to constantly loop through in the background. It actually runs in a separate thread, and it will ensure that the wrist stays at that position, at the stowed position, until we tell it to go somewhere else.
So because it's running PID in the background on its own, it doesn't need a default command. By default, it will go to whatever the last set point was. So rather than saying always go to towed when another command isn't one, it defaults to whatever the last set point was.
Yes, it is a really cool thing about PID subsystem. It's kind of like this fire and forget mode of programming where you just tell it where to go and it just goes there and stays. And it's really nice. And you can use it for drivetrains with encoders, or you can use it with elevators and wrists like we're doing here, or other kinds of devices.
So now we just need to give it a motor and an analog input that represents the potentiometer.
So again, what we're doing is we're defining all of our all the sensors and motors that go with a particular subsystem as part of the subsystem, so that it keeps everything close together and preserves what's called encapsulation in object-oriented programming. So it encapsulates all the pieces that work together all together. So this is the analog channel for the potentiometer that's measuring the wrist angle. You saw that in the first video. One thing, as we're typing, if you haven't played a lot with Eclipse or NetBeans, tools like this, you notice that code is like typing itself like really fast. And what's really going on here is that when Alex types control space, it tries to complete whatever he's in the middle of typing. And so if you have trouble like remembering names of things and stuff like that, you just do that and it pops it right out.
It also automatically imports it, so you don't have to worry about imports.
Good point.
Which is very convenient. The next thing is, for the PID to actually work, we have to return the PID input and use the PID output. So for the PID input, it's just the potentiometer. So we just have to get the value of the potentiometer. Okay. And we just want the
voltage, right?
Voltage, yeah.
Yeah, so it's very important. There's a bunch of values you can get from an analog input. It's very important to get the voltage because our set points were in voltages. So the pickup and stow are voltages.
And then we need to actually use the output of the PID algorithm, which will be passed to use PID output as the value of output. So we just tell the motor to use that value. So that's a whole PID subsystem for the wrist.
So this is pretty cool. You'll notice that we really only typed a few lines of code. I mean, Alex typed in, maybe like modified a few lines and maybe typed in like a half a dozen lines of code, and now we get full wrist control with PID feedback. I mean, that's pretty nice. Now we've done the wrist. Now we're going to do the elevator, and it turns out that the elevator is another thing, which is a motor controlling a mechanism that has a potentiometer on it to measure its position. So you're going to see that this is almost identical to the wrist. And so that makes it even easier. I mean, as you start doing these things over and over again, you find that these things all start kind of looking the same. And it gets very easy to write, which is good, because then you tend not to make mistakes. So again, we have to define some positions for the elevator. And in this case, there's 3 positions that we want to define. One of them is the bottom position of the elevator, which is where it's going to be picking up stuff. And then we've got this stowed position, and then we've got the height of this box where it drops off the soda can. So we've got those 2 values. And again, these are just values that we wrote a little program and we ran it and measured them and saw what they were. And then that's what we're putting into our program. So later on, again, we'll look at the smart dashboard, and it's a really nice tool for being able to see what these values are.
Okay, so again, we want it to be stowed by default. So set point to stow and enable PID.
Oh, you'll notice also just above the lines that Alex is typing are some comments, and the comments kind of describe what he's doing. So you'll easily be able to do this yourself just by reading those comments that are generated as part of the PID subsystem when you create it. And now again, like we did before, we need a motor and we need a potentiometer, and the potentiometer is connected to an analog channel. So here's our new motor, which is a Jaguar. And then we put in the motor port. One thing that's kind of nice about the WPI Lab interface is that you can have potentially 2 digital modules or 2 analog modules in the C-RIO. If you've only got one, and most people only use one of each, then you only have to specify which port it's plugged into. You don't have to deal with which module it is. If you happen to have 2 modules and you've got something plugged in the second one, then you have to say which module it is. Or at least have to say that if it's the second module, and you put a 2 for the module number. But since this is not using more than one of each, it makes it real easy. Okay, then the last thing, once again, is we have to be able to have the sensor that we're using for feedback. That's the where the return PID input is. And again, we have the motor that is the output for the PID algorithm. And so we set its value from this output parameter, and that's it. And that's actually, we're done now, right?
Yeah, we're done.
We're done. So this is the entire elevator control. So now we've got fairly good elevator control. Oh, one thing I'll mention is that our elevator is kind of like is spring compensated. It's got so that it tends to be able to be driven with just proportional control. So we just have a P constant and not I and D. But as you start building larger mechanisms, you probably want to have some integral and differential control also. But by making them 0, it leaves those out of the algorithm. And so it's only doing proportional control.
Okay, so now we need to go into command base and add a new subsystem. So
remember that in command base, every time you create a subsystem, you just go over there and you put the static instances of the subsystem where the comment says to put them. See, it says create a static instance of all your subsystems. So you just do this, and that will define them all. And what that by doing that, then it makes them all easily accessible from all of your commands, because all the commands extend or they subclass command base. So these variables like claw, wrist, elevator, and OI will be available to all of your commands, so you can just use them and call those methods. So that's pretty handy. Oh, do we have to save?
Oh, no. The constructor has to be public.
Oh, yes.
You should update those templates if you want.
Oh, okay. We have a little. Okay, so what's going on here is that we kind of switched the way this stuff worked at one time, and so the templates make the constructors private instead of public, which means they're not accessible to the outside of the class. So you just have to be sure to go and change that until we publish an updated version of the plugins, which we'll do shortly. Okay, so now we want to make a couple of commands that will control these guys. And again, I think you're going to find that this is something that's very easy to do because the subsystems are designed to actually drive these things to these set points. Then the commands really just tell it to go there, and then kind of let it rip. So the first one is this: will let us set the wrist set point, and so when you do that, you get just a whole bunch of methods to fill in. The first one you say is, see, it says in the comment you have to add the requires there to say that the subsystem requires the wrist, so that when you execute this command, if there's another command that's using the wrist, it will know to bump that one out and do this one instead. And we're passing the actual set point in as a parameter to this command, the set wrist set point, so we don't have to have, I mean, you could, I suppose, have one command for each position and then just have that be a constant. But instead what we're doing is we're just storing the set point in a member variable of this class. Okay, it's called set point. So we're just taking the parameter and storing it in this member variable, and then we'll just use that. And so it will just make it so we have to type less code.
So then when we initialize this command, we just want to tell the list to go to the set point that we have stored. So one of the methods of a PIDSubsystem is set point, and you get the set point, and we don't need anything to execute because PID is running in the background and you can just kind of forget about it. So the next thing is, when is it finished? And it's finished when it is within some reasonable value of close to the desired set point. So in this case, we just call it within, so if we take the current position of the list and we subtract the desired set point, and we're taking the absolute value of this whole thing, and we check that it's less than 0.08, so it's within a 0.08 volts of the desired.
And that's how we know that it's there. So as soon as the wrist gets to that position within that tolerance of 0.08 of a volt, then we know that we're there. And don't forget the absolute value function, math.abs. What that does is if the expression inside the parentheses is negative, it gives you back, it negates it and gives you a positive value. And if it's positive, it just returns the value. So that means that if it's plus or minus within plus or minus 0.08 volts from the set point, then we know that we're there.
And if you left this out, it would look like it was working, but when you go to chain commands together, as we'll show you how to do later, it will not act as you would expect. This means this command will keep running until it is there. So now we just need to do the same thing for the elevator.
So we'll make another command for the elevator. Same thing, that drives it to some set point, and for the elevator, it's called set elevator set point, surprisingly. And again, so we require, this is the same song, second verse, we require the elevator because this command uses the elevator. And then we just kind of take the set point value, which will be in a parameter in a second, and we store that away in a member variable in the class, so that whenever the command gets initialized, it can just reset it to that, and it will go to the right place. And you'll see when we use the set elevator set point and the set wrist set point commands, you'll see how that parameter is used. But it turns out it's really handy and very, very easy. So we set the set point that we stored. We do the same thing again with the absolute value. We just maybe have a different tolerance this time because, or do we? Is it the same?
We do.
We have a different tolerance this time.
0.05.
Okay, this time it's like a 5/100ths instead of 8/100ths, because that's kind of what we calculated just by playing with it. We decided it would be a good tolerance so that it stops close enough to where we need it to stop.
Okay, and that's all there is?
And that's all there is to those two. So now we now have the wrist, the elevator, and code to control them. And I guess we don't connect these to any buttons. We
can connect these to buttons for the demo.
Okay.
So we'll create 2 more buttons. And
just do a little copying and pasting.
Yeah.
Because it's always better to do that than
type out
all the 2 lines there.
So now we have
button 3 and button 4.
And now one of the nice things about how buttons work is we can just rebind the command. So we can set.
You want to make these be 3 and 4?
We can do all 4.
Oh, okay.
Because you want to be able to go back and forth.
Okay.
So the first one, when you press button 1, we'll set the wrist to be to pick up, and then button 2 will tell the wrist to stow.
So these are those parameters that we put into the commands before that say where it should go, that it's using to do the tolerance and using to set the set point. So you can see how they're used here. That you can use the same set wrist set point command to set the wrist to any position, and you'll see again it's the same thing with the elevator. So when you do the when pressed method on the button, then whenever the button is pressed, it will schedule this command. If you scheduled a command that makes the elevator go up to some position, and then as it was traveling up, you press the other button to make the elevator go down, then it will, because they both require, because these commands require the elevator, then one of them will bump out the other one, and it will immediately turn around and start going the other way. So you don't have to worry about waiting for it to get all the way up to the top before it starts going back down to the bottom. It will just stop it kind of like in flight. So that's really all it takes. So now with buttons 1, 2, 3, and 4, we can control the wrist and the elevator and make it do those commands. And we think that's right? Do we think that's right?
Yeah, it's not complaining.
Okay, good. So pretty simple, huh?
The one other thing is it's really easy to rebind buttons. So like if you're testing it and a command's not working, you can just put it to a button and then change the button again later without any effort.
Good point.
So now that we have the wrist and elevator bound to the OI, we can push the buttons and control the movement. So that puts the wrist out and that puts the wrist in. Just toe position. But if I'm going down and I decide I want to tow, it will interrupt because they both require the same subsystem. The elevator does the same thing, and it will go all the way down, and it will go all the way back up. However, the wrist and elevator do not require the same subsystem, so they can both move at the same time if we want them both to go down. And we can just tow them both at the same time too. And that's all you need to control the PIDSubsystems with your OI.